Hello students, in the previous classes we have seen keywords, identifiers and literals. In this class we are going to see operators and also delimiters. In the programming context, operators are backbone of any operation or function. What are operators? They trigger some computation when it is been applied to the variable or constant. When we talk about operators, we also need to know about operands. Operands are nothing but variables or values. Here for example, a plus b we will take. A plus symbol is the operator which operates a and 2 both operands. Similarly, if we take 7 multiplied by 5 and the multiplication symbol is an operator and then 7 and 5 are operands. There are different types of operators: arithmetic operators, assignment operators, relational operators, identity operators, membership operators, shift operators, logical operators and bitwise operators. We will see one by one with examples. Arithmetic operators are nothing but the operators which we normally use in mathematics. First, here we are having plus, that is addition. For example, 5 plus 20 results 25. Similarly, minus, that is subtraction. 11 minus 1 which gives 10. Here instead of multiplication symbol in mathematics, in computers always we use star symbol. So 100 multiplied by 5 results 500. And then exponent. Exponent is nothing but the power. So to get the power, we will be having 2 times the star symbol. For example, 5 star star 2, that is 5 to the power 2. So that is 5 into 5, 25, it will be resulting. Division, first operand divided by second operand. Here we should note that the result is given with the decimal places. For example, here 44 divided by 8, when we divide we get 5.5. Addition, subtraction, multiplication, all these, it depends how we give the input. If we are giving input with the decimal place and then output also will be with the decimal place. Here next we are having modulus, which is percentage symbol. This percentage symbol is an operator which returns the remainder when first number is divided by the second number. For example, 62 mod 6. That means 62 10 times it goes and then 2 is the remainder. It doesn't take a decimal form and then it returns 2 as the result. Next we are having floor division. Floor division is nothing but it divides and then leaves the decimal places and then gives only the integer value. For example, 58 floor division by 10. Actually, if it is normal division, it will be 5.8. It will not take 0.8 and then it gives only 5 as the result. Here all the operators used 2 operands. Python also provides an operator where one operand can be used. That is called unary operator. So there are 2 unary operators, that is plus and minus. When we say plus, that is also a binary operator, so we always call it as unary plus. For example, a is equal to 10, then plus a, that results plus 10, but we cannot differentiate it. But at the same time, unary minus. So if a is 10, if we say minus a, see now it negates the value. That means it becomes minus 10. All the arithmetic operators are also binary operators. That means all these requires 2 operands to operate. Next we will see relational or comparison operators. Relational operator determines the relation between 2 operands and results as Boolean literal. That means it will produce a result as true or false. As it compares 2 operands, it is also called comparison operator. We are having totally 6 operators here. First one, it is lesser than. This symbol in the keyboard you can find just above the space bar in the right side. See, the point is facing left side. The first operand, that is left side operand, should be smaller and the right side operand should be greater. It checks whether the left operand is smaller than the right operand. For example, 6 lesser than 25. So it is correct. So it will produce true as a result. Next we are having greater than symbol. The left side operand should be greater than the right side operand. For example, 102 is greater than 50. This is also correct, so it results true. Then here we are having lesser than or equal to. It should be lesser than or equal. For example, 35 is lesser than or equal to 30. It is not correct, so it will be resulting in false. Next one, greater than or equal to. 71 is greater than or equal to 75. So this is also not correct, so it produces false. And then equal to 2 times we give. It checks whether both the operands are equal. For example, 100 is equal to 100 we give. So it is correct. So it produces true as the result. See, here you need to remember, if you are giving one single time equal to mark, it assigns the value to the variable. 2 times you give equal to together and then it becomes the relational operator. It checks whether both the operands are equal or not. Next we are having not equal to. This is written using the exclamatory symbol and an equal to mark. It checks whether both the operands are not equal to. 18 is not equal to 20. That is true. Now let us go to Python ideally. Let us check all the arithmetic operators. First we will have addition. First operand I give 20. And the operator plus I give 30. See, we are having two operands. So this is binary operator. So 50 is the result. Similarly, subtraction and multiplication. Then we'll check the exponent. That is 5. 2 times star I give. That is 5 to the power. And then 3 I give. So 5 into 5 into 5, 125 we will get as a result. Next we will have the division operator. For example, I give 40 divided by 10. Unlike others, we will have with decimal place. Next, modulus. So that is a percentage symbol. For example, if I give 12 modulus 10, it will produce 2 as the result, as it is going to give the remainder. Now floor division. 59, 2 times division symbol I give and then I give 5. Normally if it is ordinary division and then it will say with the point, that is 11.8. But here we will get only 11. All these are using two operands, so binary operators. Now we will see the unary operator, where it will use only one single operand to operate. I say A is equal to 20 and then I say plus A. We will have 20 only, but as plus 20, the plus is not shown in the result. So we can't see the difference here. At the same time, if we give minus A, we will be able to see the difference. It will show minus 20 as the result. So as we are using only single operand, it is called unary operator. We call it as unary plus and unary minus. Next we will see some examples for relational operators. 5 is greater than 10. Is it true or false? It is not correct, so it will be false. 65 is lesser than 100 is true. 70 is greater than or equal to 70. So it checks even the equality, so it is true. 83 is lesser than or equal to 100. So this is also true. And then checking only the equality. 22 is equal to 22. So it is true, right? At the same time 23 is equal to 21. If I give, it is not true. And then not equal to is using exclamatory mark. I give 10 is not equal to 10. So it is false. Assignment operators. Assignment operator is equal to symbol. This always assigns the value to the variable which is left side to the operator. For example, we are having m is equal to 5. Value 5 is assigned to variable called m. Assignment operator equal to can be combined with other operators which assigns new result to the same variable. For example, here m plus equal to 2. The meaning of this is m is equal to m plus 2. So what happens? 5 plus 2 is assigned to the variable m. Similarly, we can also combine with other operators like subtraction, multiplication, and then also exponent and division, modulus, and then floor division. This assignment operator can also be combined with other operators, that is other than arithmetic operators. Let us understand by executing it. Now let me consider m is equal to 25. So if I give m plus equal to 20, then the new value of m will be 45. So the value is overwritten as 45 here. Let us have the same value. Let me give m minus equal to 10. So now m will be 35. Similarly, m divided by equal to 5. So 35 divided by 5 is 7. Now let us get the exponent m star star equal to 2. So 7 sevens are 49 will be the answer now. See, as before I told, 7.0 is there. 7.0 into 7.0 it gives 49.0. If it is only 7 without a decimal point there, then it will give 49 alone without 0.0. Let us assign some other value to m. M is equal to 100. Now m floor division equal to 22 if I give, the result will be only the integer part, not the fractional part. Logical operators. There are three logical operators. The first one is AND, the second one is OR, and the other one is NOT. These logical operators works on relational expressions as well as numbers or strings or sequence. If we check with the relational expressions, the AND operator evaluates true if both the conditions are true. For example, I have two expressions with logical operator AND. 5 is greater than 1 and 10 is lesser than 15. See, if you take 5 greater than 1, that is true, and 10 is lesser than 15, that is also true. So if both the expressions are true, then this AND logical operator results with true. Next, OR operator. Either one of the expression is true, then it will be evaluating as true. So for example, 5 is equal to 6. See, actually this is not correct. So that means false. 5 is lesser than 15. That is true. So false or true, it gives true as the output. NOT operator. See, NOT operator complements the operand. NOT operator works with only single operand. 5 equal to 6. It checks whether 5 is equal to 6 or not. So this is false. So not false, that is complements it, it becomes true. We will see all the combinations as truth table. For AND here, false and false results false, false and true is false, true and false is also false, true and true only becomes true. So either one of the expression is false, it gives false only as the output. So this is AND operator. Now if you see OR operator, either one of that is true and then it results true. False and false, both are false, so it is false. False and true, so there is one true, so it is true. True and false, again one true is there, so it is true. True and true also true. NOT operator, so if A is false and then it gives true as a result. If A is true and then false is the result. Now next we will see how it works on numbers, strings and sequence. See here, numbers or strings or sequence has either it is true value or false value. Don't take it as a literal, as a constant true or false. You consider here as that value which is true value or false value. To represent it, I have given true and false completely in the small letters. Known type, you know, that is always false. Boolean false literal is there, that is also false value. If you take number, so that is 0 or 0.0, otherwise imaginary number, that is 0j. If you take any of this is false value. Any empty sequence, that is false value. Any empty mapping, so that is dictionary, we will see later about that. Just you remember now that empty mapping also false. All values other than these are considered as true values. You please remember this. Now let us check how it works on AND operator. If A is false and B is false, both are having as false value, and then A is returned as output. False value and true value. So that is, if A is false and B is true, and then the value A is returned. If A is true and B is false, and then B is returned. If A is true and B also true, and then B is returned. See, remember here, false and false gives A, means whatever is residing in false, that only. False and true, it gives false as a result, because we already learnt false and true is false, right? So the value in A position will be returning. Similarly, true and false, it is there, it gives false only as the result. If true and true, then B as a result. You also need to remember that if first value is true, then only it will evaluate the second value whether it is true or not. Even the syntax is wrong, it will not check at all. If false is found as the first value, it returns immediately as false. It will not check whether the second value is true or false. Now let us check OR. If A is false and B is false, the value B is returned. If A is false and B is true, either one of these two is true to be returned. So automatically B is returned. If A is true and B is false, A is been returned, that is true value, and then A and B both are true, and then A is been returned. Not, it automatically complements. So false value is there, it gives the true as a literal. You remember, this is not as the value, it gives as a literal. Similarly, if true value is available there, and then it gives false. If you are not clear still, by these examples you will get to know how it works. Take this example, open and close single quotations. So that means nothing is inside. It is an empty sequence. AND operator, and pen is inside the single quotation. That means it has some value. So it is true value. False value and true value. So false and true means it will be returning false, that is A's value. So A's value is single quotation open and close, it returns that in a output. The second example here, something given inside the quotation, that is true value. Here also it is true value. True value and operator true value. True and true, it evaluates B's value. So B's value here, whatever is there is Python there. So Python is been returned. Here you can see open and close curly brackets, which denotes a dictionary, empty dictionary. So that means it is false value. Similarly, 0.0 is also false value. It is false or false. So both are false. It returns the value which is B. So that is 0.0 is been returned. Now not 10. So 10 is some value. So that is true value, right? So not true, that becomes false. Let us also execute and check so that it sets in your mind very clearly. Now let me take 10, which is true value, and I have book as a string. So this is also true value. True value and true value will be returning the value which is at position B, that is book, is going to be the output. Now I am having 0.0 and 75. So AND operator has been used. This is false value, and then 75 is true value. When it is false, it will not care about what is there next operand. So automatically it gives 0.0 as the value. And then now 100, and I have empty quotation. So which is true, if in case it is true, and then it goes to the second operand to check whether it is true value or not. So now it is false value, it will be returning the false value. I have here 0j, that is false value, and then r 25, which is true value. Here or operator is there, the second value which is 25 is true, so automatically it will be returning 25 as output. Now I am having 1000 or I have empty sequence, so this is true value or false value, it will be returning the true value, that is 1000. Next I have computer in the quotation, which is true value, or, and then I have mobile here. So true value or true value, it gives A's value, that is computer. Next, not. I have not 50. 50 is some value, so that is true value. So not true will become false. Next we are having bitwise operators. Bitwise operators are similar like logical operators, but here we are having 4 operators. These operators works on binary. First we are having AND. We call it as bitwise AND. For example, if A is equal to 1 and B is equal to 0, A and bitwise B gives false, that is 0. That is A and B, true and false gives false, but as binary output, that is 0. Next we are having bitwise inclusive OR. Normally we call it as bitwise OR. If A is equal to 1 and B is equal to 0, same value we will retain here also. A or B will result in 1. Next, bitwise exclusive OR, that is XOR. Here if both the operands are same, and then it results 0, otherwise it gives 1. Here A XOR B, 1 XOR 0, this will result in 1. Next we are having bitwise complement. It is also called bitwise ones operator. For A, the output will be minus of A plus 1. Here bitwise complement operator, B is given, that is 0, it will be resulting in minus 1. Here I have a truth table for you. First let us see for AND. If A is 0 and B is 0, A and B is 0. 0 and 1 results in 0, 1 and 0 also results in 0, 1 and 1, that is true and true, will be giving true, that is 1. Next, A is 0, B is 0, then A or B is going to be 0. 0 and 1 is 1, 1 and 0 is 1, 1 and 1 also 1. Next, XOR 0 and 0, so that is both are similar, it results in 0. 0 and 1, it is 1, 1 and 0 again 1, 1 and 1 is similar, so it returns 0. Bitwise complement, 0 complements as 1, 1 is complemented as 0. Next we are having identity operators. There are 2 identity operators, one is is and other one is not. Is, if both the operands are pointing same memory location, returns true. For example, let us have A is equal to 5, B is also 5, and then now A is B. So both are having same value, that is same memory location it denotes. So it will result as true. Is not is opposite to that, if both the operands are not pointing the same location, and then it will be giving false as output. Next we are having membership operators. Here also we are having 2 operators, one is in and then other one is not in. In checks whether the variable is in sequence. If it is there, and then it will be giving true as output. See here, app, that is a string in application. See, if you check, app is a part of application string, so that is true. Next we are having not in. It checks whether the variable is not in the sequence. For example, text, not in textbook. See, actually text is a part of textbook, so it is false. Next we are having shift operators. This also works with the binary. Two angle brackets together mention the operand which is left side is been moved to the right by the number of bits specified by the right operand. For example, I have 1001 binary number, right shift operator, and then 2. This 2 says how many digits the number moves right side. So here it will move 2 digits. That means 0 and 1, last 2 digits will be moved. So no further places available there. So it is been removed actually. Then it becomes only 1 0. Similarly, left shift operator shifts the binary number to the left side by number of digits specified in the right side. For example, same 1001, but it shifts 3 digits to the left side. That means 1001 is moved 3 digits. So where the empty places are there, zeros are filled. So now if you see, automatically the value changes like 1001 000. I will demonstrate all these operators using Python ideally. Now bitwise AND operator. It works on binary numbers we know. So first operand I give using 0, B, and then 1, AND operator 0, B, and 1. So 1 and 1 will be resulting in 1. The output is with decimal number system. Let us see one more example. 0B 0 and 0B 1. So it should be result in 0. Now let us see OR operator. 0B 0 OR 0B 1. It will be resulting in 1. 0B 1 OR 0B 0. So it will be resulting in 1 again. Let us see now XOR. If it is similar and then 0 is the output. So 0B 1 XOR and then 0B 1. So it will be resulting in 0. If it is 0 and 1, let us check 0B 0 bitwise XOR 0B 1. So both are different. Now it will be resulting in 1. Now let us see bitwise complement. If I see bitwise complement of 0, it will be -1. Next we will see identity operators, that is and is not. If address of the memory locations are same, and then it will be resulting in true, I said. Instead of putting the value in the variable, it denotes the address. This I will explain you in the future classes in detail. For now, I just say A is equal to 10 and also B is equal to 10. Now the address of A and B, both the variable will be pointing to the same memory location. So it will be resulting in true if I give A is B. So that is true. Similarly, if I say A is not B, then it will be giving false. Next we are having membership operators. It is nothing but in and not in. Python in Python textbook. See, Python is there, right? So it will be giving true. Now if I say py not in Python, so it is false. Shift operators, this also works on binary. 0B 10010 I give, and then shift operator right side shifting 2 digits. So at last 1 and 0 will be removed, only 100 will be there. But it will be showing the output in the decimal integer. We will just convert into binary and check. Binary of 4. So it is 100. You can see 100, before that 0b denotes binary number. Now left shift operator, 0b, I say 1111, again 01, shifting 3 digits. So 3 zeros are added to the right side. That means it moves 3 digits left side. The empty spaces are filled with zeros. So now the answer is 488. If we check what is the equivalent binary, then we will come to know binary of 488, the previous number with that 3 zeros added in the right side. So that means the number moved to the left side 3 digits. At last, in the tokens we have delimiters. Delimiters are also known as punctuators or separators most of the time. They give the structure to the programming language. The most commonly used delimiters of Python programming language are parenthesis, square brackets, curly brackets, all these used for grouping, and then dot, comma, semicolon, colon, at the rate, all these are punctuation marks. Even arithmetic operators and assignment operators, even bitwise assignment operators, all these are also delimiters. Usage of these delimiters will understand better when we are doing the programming. Students, I hope you understood all the topics clearly. Keep watching my channel, learn more. Thank you.